right, guys, hope you are doing well. Let's go ahead and get your homework out from last night, which was page 154 to 155, numbers 20 through 26 even, and 38 through 44 even. So let's get those out, okay? And I'm going to go over that real quickly, and you can check your work as you're going along here. And then after that, you guys will should have your guided notes for section 2.9, and you will fill in your guided notes as I'm teaching. Okay, first ones. Problem number 20 said just to solve the absolute value of negative 2x is less than 2. So remember on these inequalities, first thing you want to do is isolate the absolute value, which it is, and it's less than, it's an and. So I make two inequalities. I say negative 2x is less than 2 and negative 2x is greater than negative 2. So you flip the sign and make this opposite. Now I have to divide each of these by negative 2. And when I divide by negative 2, don't forget you flip the inequality sign. So this becomes x is greater than negative 1 and x is less than 1. So when I graph this is all the numbers bigger than negative 1 and all the numbers less than positive 1. So it's everything between. So your final answer that you should have is negative 1 is less than x, which is less than 1. Hopefully that one was pretty easy. Problem number 22. Sorry, I was just grabbing a book here. Problem number 22. I have to isolate that absolute value first. So we're going to add 56 first to both sides. When you add 56 to both sides, you get absolute value of 8x is greater than or equal to negative 16. Again, it's greater. It's an or, so I immediately put or in between. Then I said 8x is greater than or equal to negative 16, or 8x is less than or equal to positive 16. I divide both sides by 8, so I get x is greater than or equal to negative 2, or less than or equal to positive 2. Put it on a number line. Now, this was one of those weird ones because it's all the numbers that are greater than or equal to negative 2, or less than or equal to 2. And since it's an or, it's anywhere there is a graph. And in this case, that would be all real numbers because all of our numbers are either greater than or equal to, they're either bigger than or equal to negative 2 or less than or equal to positive 2. So that one's an all real number. Okay. All right. Problem number 24. So problem number 24 asked you to solve again. And the first thing I did was, since it was already isolated, I said this is greater. So I put or in between. And then I said negative 0.5x is greater than 1, or negative 0.5x is less than. So flip the sign, make this opposite, negative 1. Divide both of them by negative 0.5. Don't forget to flip the sign when you divide by negative. So x is all the numbers smaller than negative 2 or greater than positive 2. So when I graph it, that works out to be a good old-fashioned or inequality. So my answer is just as we saw it. X is less than negative 2 or x is greater than positive 2. Okay, problem number 26. I had to divide both sides by negative 8. When you divide by negative 8, you flip that sign. So here's my isolated absolute value. Now, I know I always have a couple questions that when you make this an and or an or, which one do you use? And I'm going to tell you right now, when you make it an and or an or, you have to go to your isolated absolute value. So you're going to go to this one. And since it's less than, you're going to make it an and inequality. So I said x plus 4 is less than negative 6. And x plus 4 is greater than positive 6. I subtracted 6 on both of these. I got x is less than negative 10 and greater than 2. Think about that. All the numbers that are smaller than negative 10 and greater than 2. Well, there is nothing. That's an and, so it's no solution. All right, problem number 38 was just an equals sign. So now we went from inequalities to equals. So same thing. Isolate that absolute value. So I added 12 to both sides. I divided by 8, and there's my isolated absolute value. Now what's inside here, 3x minus 10, is either equal to 4 or equal to negative 4, because this is an equation. So I added 10 divided by 3. Added 10 divided by 3. So there's my two answers. Now, to graph that, when you graph numbers, you just put dots on the number line. Okay, sometimes you guys have done such complex math that you forget how to do these simple things. To graph 2, you put it at 2. To graph 14 thirds, that is 4 2/3. So it goes right there. Done. Okay, problem number 40 is the also just an inequality. I thought it was a word problem, but it's not. So in problem number 40, it was already isolated. It's less than, so I put an and. So I took what was inside here. 2x plus 1 is over 5 is less than 3. And 2x plus 1 over 5 is greater than negative 3. I multiply both sides by 5. Subtract 1. Divide by 2. I get x as a number smaller than 7 and greater than negative 8. So when I graph it, I need everything smaller than 7 and bigger than negative 8. So this is an in-between problem. So it's everything between negative 8 and 7. Done. Okay, 42. 42 is just a normal problem again. Add 10 to both sides, you get 18. Now that you've isolated, it's less than and. So I took what was in here, less than equal to 18, and flip this, make that opposite, greater than or equal to negative 18. Subtract 5, divide by negative 6. When you divide by a negative, flip the sign, flip the sign. So I have x is greater than or equal to negative 2.16 and less than 3.83. So I graphed that and said, yeah, that's everything between. Now, I prefer the fractional answers. I will accept the decimals as well, and I wrote the decimals. So either with that, or if you have negative 13/6 is less than or equal to x, which is less than or equal to 23/6, that's fine too. Okay, 44 was the word problem. IQ scores for the middle 50% of the population can be written as this inequality, where X is a person's IQ score. Write and solve a compound inequality that shows the interval for the IQ scores for the middle 50%. So basically, this is just a big word problem to say, hey, solve this and tell us what the middle 50% of the IQ scores are. So it's already isolated. It is a less than, so it's an and inequality. So I made it an and. I took this as less than or equal to 2/3 and greater than or equal to negative 2/3. I don't like this 15 in the bottom, so I multiplied both sides by 15. When I do, this 15 is going to cancel. I get x minus 100 is less than or equal to, that'd be 30 divided by 3, which is 10. On the right side, when I do the same thing, the 15s cancel. I get x minus 100. That's negative 30 divided by 3, which is negative 10. Now I added 100 in both cases, and I get that. So x is less than or equal to 110 and greater than or equal to 90. So it's everything between 90 and 110. Okay, hopefully that wasn't too bad. We'll continue to work with these and review these. You do not need to turn your homework in. Okay, at this point, you guys should have guided notes for section 2.9, which is our absolute value section. And this is the last section in chapter 2. So go ahead and make sure you have your guided notes, and let's fill these out as you're going along. Okay? All right, absolute value. One thing about absolute value, hopefully you guys kind of remember from previous years and even earlier this year, I added this to our families of functions because I think it's really important that you guys know absolute value. So when we have y equals absolute value of x, what does that look like? So our parent function, y equals, or f of x equals, either one, the same thing, f of x equals absolute value of x. If we make a table of values, and here's a table of values, and in this table of values, I'm not sure if I left the values that I have on my chart up here, and if so, I'll show you in a minute, but I'm going to use -2, -1, 0, 1, and 2. So absolute value, well, what's the absolute value in -2? Because you just plug it in. Absolute value of -2. Absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So hopefully you guys remember that your graph for this is a V shape. So at -2, you have 2. At -1, you have 1. At 0 is 0. 1 is 1. And 2 is 2. So your graph is a V that goes on forever in this direction. So your domain is all real numbers, okay? All real numbers, or -infinity to infinity, because it goes left forever and right forever. But your range In this case, y is everything greater than or equal to 0, or it in smaller number is 0, it goes up to infinity. Okay? And the vertex of this graph is this corner point right there. The vertex of this graph is 0, 0. So hopefully you remember all of that from the parent function when we studied this earlier this year. And here it is again in the chart. So they use -10, -5, 0, 5, and 10. Absolute value -10 is 10, and so on. So it's the same thing. We got our domain, our range, and our vertex. Okay. This next part is exactly what we learned for linears earlier this year. I think it was maybe section 2.6, but I'm not 100% sure. Okay. If you have the parent function, f of x equals absolute value of x, what is happening to these graphs? So let's talk about this. What's happening to the graph g of x equals absolute value of x plus 2? If it's outside of the absolute value, this goes up 2. Okay, the absolute value kind of acts like parentheses. If I have absolute value of x minus 2 on the outside, that goes down 2. So these rules have not changed from the linear. Okay, but if I put it inside, it's kind of like putting it inside the parentheses. Remember, this goes opposite of what you think. This would actually go to the left too, and we talked about why that is, and it has to do with the x-intercept. If you want to find the x-intercept of this graph, you want to let y be 0. So remember, what would have to be x to let y be 0? It'd have to be -2. So the x-intercept's at the point -2, 0, which means this thing shifted to the left 2. So that's why it's left 2. Okay, and then same thing if you have -2, so inside the absolute value, x minus 2. Hopefully you guys remember that that goes right 2. So I told you guys that we'd come back to these rules, and here they are again. They don't go away. Okay, all right. Perform the transformations of f of x on f of x equals absolute value of x. So we got the parent function, then graph the parent function. So here's what I do. Guys, you can graph the parent function in 2 seconds. The parent function goes through 0, 0, and the right side has a slope of 1, and the left side has a slope of -1. So here's your parent function. I mean, you can think of this as your parent function. So this is f of x equals absolute value of x. Okay, now they want you to go down 5 units. So we all know if you go down 5 units, it's just absolute value of x minus 5. So here's your equation. And you just take each of these and you shift them down 1, 2, 3, 4, 5. So you go down each of these 5 units. Notice where your vertex is. My vertex was at 0, 0. My vertex also shifted down 5. It is now at 0, -5. And it has arrows because it goes on forever. Okay, pretty simple. How about this one? Again, take the parent function, which is 0, 0, 1, 1, 2, 2, 3, 3, and then this one has a slope of -1. This is your parent function. So this is the, I can't even leave that. That's so sloppy. Okay, try it again. There's that side and that side. Okay, so this is our parent function, f of x equals absolute value of x. If you want to go 1 to the left, remember left is inside the absolute value and left is opposite of what you would think, so it's +1. So here is your, that's an absolute value. Here is your equation, and then you just take each of these points and you shift them to the left 1. Notice your vertex was at 0, 0. It's now over here at -1, 0. And then here's the rest of them. So this shifted to the left 1. So these graphs are really easy to make. The thing that I am most important about is where did your vertex shift to? So make sure your vertex is at the right spot, okay? All right. Well, we've talked about shifting up, down, left, and right. there's a formula that the book gives you, and it talks about the vertex. And I'm going to tell you, I don't memorize this formula. I think there's an easier way to do this. You can, but I don't think you have to. If I always tell my students, think of this equation. G of x equals absolute value of x minus 3 plus 4. I always tell my students, ask yourself, what is happening to this graph? Which way is it shifting? So the minus 3 is making it go to the right 3. And then the plus 4 is making it go up 4. So think of your vertex. Your vertex was at 0, 0. It now went right 3 and up 4. So where's your vertex? Well, your vertex is at the point 3, 4. So I always just think about what happened to this. Now, they have g of x is equal to absolute value of x minus h, because this is always opposite in here, plus k. So this would be a vertex of 3. It's opposite here, 4. So if you want to use the formula, use the formula. If you want to just think of it of which way it's shifting, that's the way I like to do it. Absolute value of x plus 1 minus 2. So I like to look at this and think, okay, which way is this shifting? It's shifting left 1 and down 2. So I envision in my head, I don't even draw this. I just envision in my head, left 1, down 2. There's my vertex. So it's now at negative 1, negative 2. Opposite, same, negative 1, negative 2. So if you want to use the equation, want to use what you already know about x and y, in how this thing changes, go for it. Okay, so example 2. Translate this graph so that the vertex is at this point. So here's what I do. I'm like, okay, where is the point negative 1, negative 3? I want the vertex to go to negative 1, negative 3. So where do I want this graph to go? I want it to go left 1 and down 3. So what would my equation look like? Anytime it says translate, we want you to tell me the equation. So the new equation would be what? Well, if I go left 1, it's x plus 1, and then down 3, minus 3. Here's my equation. Now, how about my graph? The right side has a slope of 1. Left side has a slope of negative 1. I'm done. That's all I do. It's really simple to graph these. Absolute values are very, very simple to graph. Okay. Well, now we're going to talk about reflections across x and y and horizontal stretches and compressions. So the best way to do this is ignore all of that and come down to an example. So what if I give you that f of x is equal to the absolute value of x plus 2? So there's our original function. If I want you to reflect about the x-axis, okay, reflect about the x-axis. We talked about this before. If you reflect about the x-axis, you make y negative, and y is everything. This is the whole equation. So I'm going to make the whole equation negative. Now, here's the important part about distributing this negative. When you distribute a negative, you are never allowed to distribute it into the absolute value, because that has just totally changed the value of this, because now you've made that a positive when you put it in the inside. So we're going to put it out front. So when you distribute to an absolute value, you got to put it in front. So this goes there, and then we distribute it to there. So when I clean this up, I get negative absolute value of x, and then a negative times a positive is a negative 2. So this would be my reflection about the x-axis. Okay, what if I reflect about or across the y-axis? Okay, well, when I reflect across the y-axis, remember the only thing that you make negative is the x. The x is the only thing that changes. So I'm going to come in here and say absolute value of negative x plus 2. Now, I'm going to leave this for now. Hopefully you guys know the absolute value of negative x is the same thing as the absolute value of x, but we'll just leave that for now. And that's good. Okay, another one, vertical stretch by 5. Okay, vertical stretches. Remember, vertical stretches are easy. Vertical stretches y. Y is everything. So I'm going to multiply 5 by everything. And just like I did up here, when I distribute that 5 has to go out front. It cannot go into the absolute value. Okay, so when I distribute it, I get 5 times absolute value of x plus 5 times 2 is 10. This is how you would simplify that. All right, what about horizontal? Horizontal compression by 1/4. Compression by 1/4. Okay, guys, remember I said horizontal is a little bit harder. 1/4 would be 1 over 1/4. So remember, we're going to multiply x by 4, the reciprocal. So now we're going back into this equation up here, and everywhere I see an x, I'm putting in 4x. So I have g of x equals absolute value of, in here, 4x plus 2. That's the only time you're allowed to multiply inside the absolute value is when you are doing a horizontal stretch or compression. And we're done. Okay, last example then, translate and graph. So it says in this first example, A, it wants you to take this function and do a vertical stretch by a factor of 2. So remember, if you do a vertical stretch by a factor of 2, you're multiplying 2 times the entire equation. Okay, so this would be g of x. And when I distribute, remember this has to go to the front of the absolute value and then to the -1. So I get g of x equals 2 times the absolute value of x minus 2. So here's my new equation. Now, graphing this isn't as easy as the other ones. So what I always tell students is make a table of values. Okay, always go back to the quick old-fashioned table of values. And you can do that, plug in -2. Think about this. What's the absolute value? -2 is 2, times 2 is 4. 4 minus 2 is 2. Plug in -1. Absolute value -1 is 1, times 2 is 2. 2 minus 2 is 0. 0. Absolute value is 0, times 2 is 0, minus 2 is -2. Plug in 1. Absolute value of 1 is 1, times 2 is 2, minus 2 is 0. Absolute value is 2, times 2 is 4, minus 2 is 2. And now when I plot this graph, I go left 2 up 2, left 1 over 0 up 2, over 1 up 0, and over 2 up 1. And if you notice, my slope is no longer 1. Okay. The slope is no longer 1 on these because I have done, just pretend that's a straight line. Okay, I got to use a line feature because that's just so terrible. Okay. There we go, and there we go. So this would be my V, goes on forever in both directions. Notice that my slope is no longer 1 because I have done a vertical stretch by a factor of 2. So I have stretched that out. Now, I do want to show you how you could do this on your graphing calculator. So if we go to y equals, the last time we graphed, we were doing regression. So we need to clear all this out. The most important part, when you go back to graphing functions like that, you have to turn your plots off. That'll be one of the biggest errors. You guys come up and say, my calculator isn't working. It's not your calculator that's not working. It's user error. When you're graphing functions, turn the plot off. When you need to go back and turn scatter plots on, you turn your plot back on and go up, hit enter, and come down. It turns it on. But right now I want it off. So I'm going to turn that off. And I'm going to graph 2. And then the absolute value is under math. And then I think it's under number. Yeah. So I went to math and then over to number, and it was right there. So that stands for the absolute value of x. Now, those of you with the newer calculators, it puts the absolute value there. It's so nice. And then you can just close your, get out of the absolute value, go hit the right arrow button right here, and it'll get you out. So you can literally make yours look like that. But those of us with the older calculators, we have to put like that. Now, the last time I graphed my window, it was this crazy window from my statistics. So I'm going to go back to Zoom, and this time I'm going to do 6 because I'm going to go standard back to my standard window. And you can see your standard window. Now, remember, if you want to see your table, you can see your table. So I went to second table, and at -2, I have 2, and at -1, I have 0, and 0, -2. And so you can go through and see your table. Okay. All right. B, let's do this one. Stretch it horizontally. So we're taking this function. Oops, I missed hang on a second here. We're taking this function. Heavens. We're taking this function, and we're doing a horizontal stretch by 2. Remember, horizontal is harder, so we're actually going to multiply 1/2 times x. So my new function, g of x, is absolute value of 4 times, I'm multiplying x times 1/2 minus 3. Well, 4 times 1/2 is 2x minus 3. So this is my new function, simplified right here. So again, to graph that, you could either put it in your calculator, or you could make a table of values if you want to make a table of values by hand. Sometimes I think this is just as fast. 2 times -2 is -4. Absolute value of -4 is 4, minus 3 is 1. 2 times -1 is -2. Absolute value of -2 is 2, minus 3 is -1. 2 times 0 is 0. Absolute value is 0 is 0, minus 3 is -3. 2 times 1 is 2. Absolute value of 2 is 2, minus 3 is -1. 2 times 2 is 4. Absolute value of 4 is 4, minus 3 is 1. There's your table of values. Or throw it in your graph, your graphing calculator. So over 2, up 1, -2, down 1, 0, -3, over 1, down 1, over 2, up 1. And here is your V. Oof. Oh gosh, guys, I'm sorry. Okay, let's see if I can. Pretend that's a straight line. Okay, a V. All right. Okay, so you guys are done. You can go ahead and start your homework. And your homework tonight is on page 161 to 163. Okay, so it's on the board. It's on Canvas, but just in case you don't see it, it is page 161 to 163. Numbers 9 through 23 odd, 9 through 23 odd, 27 through 29 all, and 38. Let me double check that. 29. Yep. Okay, have a good day, guys.